So now I try to introduce moving pictures, which was prepared by Japan Society of Civil Engineers.
Infrastructure is the domain of the civil engineer. It is civil engineers who design, build, and maintain the public works which constitute the physical framework of the civilization we enjoy and often take for granted. In the course of the 20th century, we have seen achievements in this field that our ancestors could never have imagined. As the momentum of our technical success carries us forward into the 21st century, it is time to review where we have come from, what we have learned, and where we are going. The Alps loom like snow-capped giants, barring the way to travelers between the Italian peninsula and the world to the north. These mountains in the roof of Europe are typical of the challenge which civil engineering was created to overcome. The world's first modern mountain tunnel came into being here, born in the railway building frenzy that sprang from the Industrial Revolution. Dynamite and rock drills used in the Alps in the 19th century launched a new era in the art of tunnel making. Today, the St. Gothard, the world's longest highway tunnel, runs 16 kilometers through the Swiss Alps. The evolution of tunnel technology from the 19th century to the present has not been easy. In mid-20th century Japan, the Tana Tunnel and others were built by what was at the time the most up-to-date technology, but the operation was still labor-intensive, plagued by floods and the ever-present danger of collapse. Elaborate scaffolds were devised to keep the ground in place, but structures of wood and steel can only provide support at certain points, and the trouble may begin at any point. Rock is typically fragmented, and the cracks are often filled with sand and clay. Under the influence of gravity and seepage, these work loose. A piece of rock falls out, and then another. Disintegration is underway. In 1962, an Austrian tunnel engineer, Ladislaus Lewusewicz, came up with a new idea. The principle of the new Austrian tunneling method, or NATM, was to transform the fractured surface of the tunnel into a continuous self-supporting arch. Wet concrete is sprayed over every inch of the walls and ceiling of the tunnel. The concrete lining prevents the escape of the bits and pieces which, if they're kept together, give the arch its natural strength. The concrete fingers of the lining reach into cavities, uniting rock and concrete in a single purpose. Successful technologies spread rapidly in a shrinking world, and widespread use improves them. Japan is largely mountainous. Tunnels are links in its communication infrastructure. The new Austrian method was used to make tunnels for bullet trains and highways. Timing was crucial to the method's success. After the initial excavation, the concrete lining had to be applied to the raw surface as quickly as possible, leaving no time for rock to start deteriorating. The stability of the lining is enhanced by using iron rods called rock bolts. The rock is drilled to receive them. The bolts are cemented deep within the rock and serve as anchors. The rod with its plate keeps the concrete sheath secure and the tunnel intact.